looking at the data with Buckaroo. So I was an early employee at Anaconda. I worked on Wakari, which was a hosted Jupyter notebook, but we called it IPython back then because they hadn't changed the name. It's a hosted IPython notebook environment. I was a core contributor to the bokeh charting library. And then I was a quant dev at various hedge funds. And I did a lot of work with data there. And a lot of what the traders, the way they wanted to look at data was very influential to me. I've been a long time user of pandas and dataframes. And I've also worked at Flatfile where I made user-facing self-serve data cleaning tools. So for a little bit of context, I'm going to show you a quick view of what we're going to be talking about today. This is Buckaroo. So how many people here have used Jupyter notebooks? Okay. How many have used pandas? Okay. Buckaroo is this data table, and I'm going to talk more about it for the rest of the talk. So I'm going to go through the minimum checks I do on each new data set, Buckaroo feature tour, including how you can customize it with summary stats, styling, and post-processing, the low-code UI that's built into it, auto-cleaning, builds on the low-code UI, and applications you can build on top of Buckaroo with these customizations that are there. When to customize and why, and the architectural overview of Buckaroo. I made Buckaroo because I got tired of doing the same things over and over again. I got tired of typing df.describe and df.head and then df.sort values and then df.histogram for each column. This is painful. Computers are fast. They can do all this each time you load a data frame. And then there are lots of patterns I run into where I would just clutter up notebooks trying to figure out what does this data look like. So back. Here is a city bike data frame. These are trips from one station to another in New York City. And these are some of the steps I go through every time I look at a data set, especially a new data set, but also when you're looking at a data set in the middle of a pipeline. Like, why does it look this way? So what columns do we have? And you can just scroll back and forth. You can sort by a column. So let's see the longest trips and the shortest trips. Right now we're looking at 100,000 rows. Sometimes you'll look at a individual value. So Sullivan Street. Let's see how many rows include Sullivan. So we have 648 rows that include Sullivan Street, and it's also rerun the summary stats for this reduced view. You have summary stats here. You can see D-type, non-null count, null count, unique. When we search for Sullivan, all these values will update. They've updated. I remember one time when I was working at the hedge fund, I was going through a model with a trader, and I said, okay, your data frame comes in here, and we do this transformation, and then that transformation, then down here. And that's how we get this result. And he said, well, this isn't the result I want. I'm like, okay, well, which transform don't you like? And he said, what does the data say? And at every step, he's like, what does the data look like? You need to look at your data. Like, you can make all these assumptions, but sometimes things are really made clear if you actually look at your data. All these steps we just went through, what we haven't done is created a bunch of notebook cells. We haven't cluttered up our notebook, and this is all there and accessible. And I can re-execute this. Yeah, it's about a second. It's just faster than I could type any one of those single commands. Yeah, so look at your data, and we're going to talk about other stuff, but if you're using a notebook environment where you have to type df.head, or look up pd.set options, just stop doing that. Use Buckaroo or a similar tool. Import pandas as PD, import Buckaroo. When you import Buckaroo, in most notebook environments, it overrides so that it is the default data frame display method. And there are ways to undo that, but I assume you want to use it interactively, so that was the choice I made. I was frustrated with simple tasks like looking at the data. Why did I name it Buckaroo? Buckaroo helps you wrangle data. This is a lot of what your job is, so that's what I called it. And it's hard to write reusable data frame functions. As we get into how to customize it, I've had notebooks where, okay, here's my summary stat. Let me iterate over the columns and iterate over this list of functions. And that works until you blow up in the middle of 2 nested for loops. And you can't even tell what function blew up or what column it blew up on. Or you could write one really long function, but that's hard to reuse. So I'll get to how I solved that in a second. And I just thought this should exist. Like, we shouldn't be going out to Excel. This should all be in the same environment. Speed, why it matters. Okay. Here's a data frame with $150,000 rows and 100 columns, and we can scroll through it. Because Buckaroo is fast, and there are a lot of features built in it which make it fast, you don't have to worry as much about how big a data frame you're loading. You have to use df.head and those other methods because your web page will get too big in your Jupyter notebook, or the performance will just be really poor. Speed lets you not worry about that. Works with polars also. So here is the same, oh, need to restart this. But anyway, does work with polars. And works with polars. Has anyone here used Marimo notebooks? Yeah. So it works in Marimo. It works in Visual Studio Code. It works in Google Colab. So you can use the same tools you want to use in different notebook environments. It does work with polars. I'll show you that some other time. Different notebook environments, you just went over that. It also works in Jupyter Lite environments, so the WebAssembly modules. So I have a lot of links where you can just go to a Marimo or Jupyter Lite notebook, and Python is compiled to WebAssembly, so it runs entirely in your browser. Let me show you the Dasherly data frame data set. Where is this? Building Buckaroo, I want to be able to display every data frame. I don't want people to have an error or that doesn't display. There are lots of weird data frames out there, and things that you wouldn't expect would give you trouble, they do. Like Infinity. And that's because Infinity does not serialize properly to JSON. So a lot of data frame libraries can't display Infinity. Really big numbers. You'll run into JavaScript problems here with unless you handle the types in JavaScript properly. Multi-indexes on the index and the columns. Let's see. Yeah. So these are some of the nasty data frames that I've seen that I've tripped up with, and they're all part of the unit tests library for Buckaroo. And it just shows here are things that you have to deal with. Post-processing functions. So the simplest way to customize Buckaroo is you can write a post-processing function, and that's a function that takes a data frame and returns a data frame. So looking at this data frame again, we can see we have a lot of columns where, oh, I haven't gone over histograms with you. So Buckaroo has like regular histograms. It's not that interesting on an ID column. It also has what I call categorical histograms. So for columns with a limited number of integers or string values, we have categorical histograms. So we can see that 1 occurs 66% of the time and 2 occurs 34% of the time. You can also see what percentage of the column is NA. And here there's this value or it's NA. We have special colors for unique and long tail. So like the first 3 or 4 values, the rest is long tail, and then you get another bar for unique values. But if you look through this, you have a lot of columns here where it's mostly NA. Another nice little affordance here. No, we don't have any columns like that. What are those actual values? So I wrote this Python function where I go through the columns. If that column has 99% NA, it will just filter to the actual values of that column. Then it unions that over the different columns. And we can just turn that function on here. So now we've gone from 150,000 rows to 1,700 rows. And our distributions look different. So you can actually see what are the values, and you can sort, and you can quickly get to your values. This is the type of function that I'd normally write, and like you'd have it in another cell, look at it, but you can add as many functions to the post-processing list as you want and select between them. And for this slide set, if there's a YouTube link, there's a video about it, and then there are also a lot of example notebooks in the repository. So custom summary stats. Which window is this? Here we are in Jupyter, and here I wrote a 99th quantile analysis. So you can write a couple of lines of code, and this goes to the nested for loop problem, and we just give this a display name. So now we have main, we have summary, and we have quintile 99, or quantile 99. So we see that listed there. That's the 99th quantile for each one of those values. One of the other things you can do with this is if you have an expensive calculation like value counts, you can say this analysis depends on value counts, and you don't have to recalculate that each time. And the pluggable analysis framework, which is built on forms of DAG, and says, we can satisfy that with the existing analyses we have in this set, or we can't figure that out, and you won't even run it over the data frame. The styling gallery. So Buckaroo has, darn it, I had not re-executed this notebook. This one I will re-execute. There are lots of ways you can style a column, and that also goes through the pluggable analysis framework. So here's a color map where we're just the float column is colored based on the integer column. So that's a type of styling you can apply to a column. And one of the things I'm getting to here is the histograms and the way you see Buckaroo. There are kind of two parts of Buckaroo. There is the tool you use to look at a data set you know nothing about, and then there's also the framework I use to build that tool. And every customization I've made, you can make as a user of Buckaroo. You don't need to fork it. You can just add these functions and get your own set of tools to play with. And you can do charts with all these types of glyphs. This is also in the docs. The low-code UI. So one of the pieces I was most excited to build for Buckaroo is this low-code UI. Please work. So you can click on a column, so start time, and drop the column. So start time no longer applies. We can drop another column. And now these operations you perform line up here on the bottom, like they do in CAD software. So you can quickly see which ones, and you can just delete it here. You can also see the Python code that runs to generate this. For software engineers, the really cool part of this is what you're looking at here is a Lisp code editor. There's an embedded Lisp interpreter in Buckaroo that reads JSON-flavored Lisp. And that's just easier to manipulate each one of these cells for all the different things we're going. Looking at the data, there's explanations of why JLisp and how you use it. You don't need to write JLisp. You can add a function to the low-code UI in about 5 to 10 lines of code. You write one function to manipulate the data frame and one function to output the Python code. So we go through auto cleaning with you. Spent a lot of time cleaning data, and you do the same things over and over again. So here's a data frame, and we have 4 columns here. We have a column of floats, a column that's mostly ints, but Pandas has to treat it as object because we have an A867-5309 isn't actually an integer. US dates, we have, well, we'll go through it, and mostly Boolean. That looks like it should be Boolean, but it's not. So you can imagine writing a cleaning function for each one of these. And like you can look at it and say, I think I want, if it was probably over 90%, I'd want to apply this cleaning function or that cleaning function. And that's what auto cleaning does. So this turns on aggressive, actually I'll start with conservative. So conservative, and if we turn on the low code UI, we're calling string bool on mostly Boolean. So now mostly bool is their Boolean values. And you can see the original values over here. So you can see what was on became true, no became false. And conservative says it needs to be a very high threshold to apply that particular function. There are heuristics there. Aggressive was a little bit looser, and these are heuristics that I came up with. So that has fixed mostly ints, US dates, and mostly bool. You can also do things, you can click preserve, and now that treats that function as if you put that in yourself. So you can go over to conservative, and it's still going to say string bool, but we'll keep strip int parse. And we can also see all the Python code for this because this goes to the low code UI. You can just copy and paste this into your next cell. This goes to another piece of Buckaroo as I designed it. It's hard to be opinionated writing generic data frame functions because you could have any type of data frame and you don't know what makes sense to apply when. If you make it quick to change between opinions, whether it's which summary stats you're looking at or which auto cleaning method you're looking at, you can have more opinionated analysis and just toggle between it and select the bits that you want. Maybe you just select it with your eyes, you're just going to look at that bit. Computers are fast. Like you can do all this faster than you could type any one of these commands. So that's auto cleaning. And there's once again, a video and an example notebook for that. Oh, the other thing about auto cleaning is that didn't use an LLM anywhere. That's why it's fast. That's just heuristics. And you don't have to send any data to a foreign system to run that stuff. Let me show you an application I built with all of this, all these features built together. So this is a compare tool I made where we're looking at, I don't like how it's formatted that, but we're joining two data frames on column A, and we can see this row only occurs in one of the data frames, and this row only occurs in a different data frame. For the same column, all the values are the same between the data frames. And for this column, column B, these two values are the same, and then when you hover over, you see the value for the second data frame. Once again, I built all the code to run this is in this notebook. This isn't built into Buckaroo. These are the type of customizations you can build on top of Buckaroo. Multiple views on the same data. Yep. Typing the same commands over and over again or waiting for an LLM should bother you. Like, we should have better tools that don't force us to do that. There are multiple ways of accomplishing things with Buckaroo. Think about your workflow and the things you go through over and over again. And if you want to use Buckaroo, I'm happy to sit down with you and say, help you build like your own custom widget and analysis for a reusable tool that you can use yourself or share with your team. Like if you have some type of analysis that like you have your own way of computing a summary stat, your whole team should look at that the same way, and they shouldn't have to, maybe like a library function is not a big deal, but it should all be available to them in the same view. Going through this more quickly than I expected. So how does Buckaroo work? Underlying things, we have an AG grid table. That's a JavaScript table that runs in the browser. This is using the community open source part of it. And then on top of that, I built a declarative language so that AG grid wants to be configured by throwing functions in, and you don't want to write functions in strings in Python and send them over to a browser. You'd rather just say, I want this column to be configured in this way. And that took some work, but it's done. Python AnyWidget handles the widget side of it, and that's what lets it work in all these different notebook environments. Trevor Mans wrote that, and that's why it can work in Google Colab, Marimo, Jupyter, and these other places. There's also lazy loading with Parquet. So when we go back to why it's fast, so right now there are 150,000 total rows, but we've only displayed, each time you see that flash, that's the front end calling back to the back end and saying, give me more data. So you're only sending 20 or 30 rows at a time. Those are all null. Parquet also gets types much better than JSON does. That's why Infinity works. And null exists in JSON, but the big ints, like over in JavaScript land, you're dealing with, I think it's like float. They have real types. It's not just a number. Features not in Buckaroo. There are no event handlers. When you edit Buckaroo, there's a very specific data flow through Buckaroo. And if you could just write a function, oh, change my data frame, well then how do you know your summary stats run properly? And how do you know these other things run properly? Here's my slide with the data flow through Buckaroo. I can go into more of this if you all are interested. There's no data editing. Data editing doesn't make sense in a notebook environment. So there are ways I can set it up so you click here on Swanson and you could type a different value in. You're not going to do that over 150,000 rows. Also, if I do build that feature, if you re-execute this cell, you're going to lose it. Like there would have to be a whole data saving infrastructure. It just deals with data frames. It's not built to do that. If I ever did build a feature like that, it would probably, once again, go through the low-code UI so that you can get, here's some Python code for doing these same transforms. And then you don't get setting on copy errors. And you don't have to look up syntax for doing things properly. There are no rounded corners in Buckaroo. So in my experience, there are kind of two types of UI. There's venture capital, VC UI, and then there's trader UI. And venture capital UI has rounded corners, and lots of padding. And we'll have some drop shadows. And that's great, because you're only going to display a table with 3 columns. Your freemium model with 10 rows, your mid-tier, and your callless enterprise. That's all the data you have to display. A trader is going to want every bit of information jammed into every pixel on their screen. This is the laptop I use for doing data analysis. I'm respectful of my own screen real estate and yours. So there's not a lot of padding in Buckaroo. And like that's the type of styling I can build. This is what you get. If someone wants to write a theme, I'm open to accepting PRs for it. Buckaroo does a lot of things. Look at your data. Don't use df.head. Like that's the really important thing to get out of this talk. Pip install Buckaroo. Give it a star on GitHub. Oh. Can you, the question was, can you upload an Excel file into Buckaroo? Yeah. You can use pd.read xlsx in a notebook, which will give you a data frame, and then that you can display that with Buckaroo. So Buckaroo works on data frames. Yeah.
If I wanted to run, like, while I'm like editing or filtering stuff in Buckaroo, is there any way of like seeing the different things that I did, like a log of stuff? Like first I filtered on the word Edward, and then I did these other things.
That's an interesting way of thinking about it. Not yet, but there's a feature I've been thinking about. So actually go back to full tour. Okay, so we search for Sullivan and we're down to 648 rows. What I would like to do at some point is have caching based on the parameters that went in to get your data frame to look like this. And that's going to be your search. Search also goes to the low-code UI. Whatever you've done in the low-code UI in your post-processing function. And then have options so that you can say histogram unfiltered, histogram with filter A. And once I have that, I guess you could go back through, here are the different states it's been at, and get to it that way. I could just keep a list of those states.
Like a DAG kind of thing, or maybe not a DAG, but like a,
well,
yeah, like a list of different operations.
Do you mean like, did you search for Sullivan and apply which post-processing function, or what? Do you want to tell me more about what you were thinking there?
I guess, like, I'm imagining using this and doing exploratory data analysis. And,
Mm-hmm.
in some, at least with notebooks where I'm doing stuff, sometimes I end up doing something and then I don't. It can be.
How did I get this result?
How did I get here almost?
Okay, so Buckaroo helps with that a little bit. One, if you put your functions into these reusable units like post-processing functions and added them to summary stats, you can kind of see the results really quickly, so you don't have to wonder what the value was at this point in time that you were applying that function to, so that helps. Also, I would say use Marimo. So this is a quick thing with Marimo. If we say citybike equals 3, that will be an error because Marimo makes a DAG of your notebook cells, and you can only define a variable once there. So that's kind of the best advice I have for that. In the back?
Thank you so much for a great talk, Paddy. I was just curious if you could go over the data pipeline. If you could go over that.
Okay. If you're interested. Okay. So your raw DF comes in, and then I don't have this now, but at one point you could change between sampling methods. So, and right now Buckaroo, if you have over 1 million rows, samples randomly down to 1 million rows. And then your cleaning method. So that was aggressive or conservative, and the low code operations you entered yourself. Buckaroo looks at that and just makes sure it doesn't delete anything you've preserved or typed in yourself. And from there it goes through cleaning, and it creates the clean data frame and the clean summary dictionary and generated code. Next, the post-processing method is applied, and you get the processed DF and the processed summary dictionary. And then the rest of your summary stats functions are run. All of this is merged, and it goes into the widget. So you can actually access these values. So if we go to NA outliers only, that might be a bug. We can type bw.dataflow.process. And this gives us that same data frame that you filtered down to. So for this data set, actually, I should have told you about this data set. This is a data set my cousin, who does work marketing to medical people, he found an open source data set on the government website. There was a 10 gig CSV file, and he wanted to find anesthesiologists in the list. So I went through it, and I did a couple of things. I found the anesthesiologists with their code, and was looking at the first 50,000 rows, and I sent it over to my cousin. To send it over to him, what I did was I searched for that code, which I forget off the top of my head. Then I did .2 CSV /for my cousin. And I saved it. And I could just email that to him. And then he looked at the data and he said, actually, this doesn't work for me. And a lot of times when you look at data sets, you're going to be like, this data set doesn't do anything useful for me. The quicker you can get to that, the more time you have to look at the data sets that matter. So yeah, that's the data flow through there.
Thank you so much.
You?
My question is the following. I have many questions, but the one that I think will be interesting is how much does Buckaroo do in terms of looking at the data across multiple columns? Because a lot of the statistics you showed so far are sort of applied to one column at a time. Like I can look at min-max values, get charts, that kind of stuff. But usually the interesting bit in the data set is how do different columns correlate with each other, or what's the relationship between columns? Can I find something there? Does Buckaroo help with that one, or is it maybe like just single column filtering plus some adjustments of the other column?
If you wanted to do something like that, you would put that in a post-processing function, because your post-processing function has access to the entire data frame. I'd love to talk to you afterwards about like what types of functions and like where they would display. The one thing I've thought of in that vein is sometimes I wish I could order columns. So I want my less interesting columns all the way to the right and my more interesting columns to the left. And a way of defining that is if a column is all null, there's no reason to ever look at it. That should be all the way over to the right. Yeah, I'd love to talk about that and see how something like that could fit in. In the front?
There are a number of packages that will summarize and do various manipulations with Pandera data frames.
Mm-hmm.
What sort of packages did you last use that lacked certain functions that you felt you wanted, that prompted you to create Buckaroo and incorporate whatever challenges to, and how did that differentiate? How did your package differentiate from these other packages?
So, your question was, which other packages out there do similar things to Buckaroo, especially for initial data analysis, and why did you write Buckaroo when those things existed? So some of them I didn't know existed when I started. Data profiling is a data profiling package that has a lot of summary stats, a lot more than Buckaroo does built into it. Detail is another one. And then Google Colab, VS Code, Marimo have built-in data frame viewers that they'll have a histogram there. The first part of Buckaroo that I wanted to write was the low-code UI. And I either didn't know those packages existed or you couldn't extend them in the ways I wanted to. And all of those packages are good pieces of software that people put a lot of work into. One of the differences is data profiling takes about 2 minutes to run, and it does much more thorough statistical analysis. And that's great if you decide you're going to do statistical analysis on a data set. If you're just looking at a data set, I built Buckaroo to work in the notebook flow so that you can do these checks really quickly and you don't skip them. If something's going to take a minute, I will skip it and I'll get lazy. And then later on in my analysis, I'll regret that I skipped it because I'll run into some bug later that I could have caught earlier. The other data frame visualizers I don't believe are as extensible as Buckaroo, and most of them are not as performant. Yes?
Buckaroo, can we do, say, calls specifically, like, say, I have a start station, Sullivan, and say we do a specific CSV or like a file, and then another start station, the sublet, and then eventually say we do a CSV or like a file. So can we have a saving method for each column consisting of XYZ?
So your question is, can we have a saving method for each column? A saving or styling method? What?
Yeah, essentially it's a styling way where I have, I wanted to filter out specific XYZ and I can save it out.
Save it as in how it displays, or save it as in?
You display it, but eventually I'll save it either CSV file or a PyData.
So if you're filtering, you could write a post-processing function. You might be able to do that with auto-cleaning. So one thing, type of application I'd like to write on top of Buckaroo is, imagine you have like 2 or 3 types of data frames you look at all the time, like report 1, report 2, report 3, at different parts of your system. First write a customized Buckaroo widget for each one with the styling methods, and then write a wrapper function where it looks at the data frame and just says, if this column name exists in the data frame, customized Buckaroo widget, or display it with this other customized Buckaroo widget. Does that get to?
Yeah, and I think eventually we can save it as you have shown a minute ago, yes.
And yeah, please come talk to me afterwards, and I'm happy to talk more about that and see how we can do those pieces.
Actually, I have a question, sort of maybe along that line. I think the first person who asked, it's kind of an like maybe it's a crazy idea, but like it seems like sometimes in like Google Sheets, I will do a bunch of this kind of thing, right? Just to like look at something,
Mm-hmm.
not actually do code. It's awesome that like this thought about like if you could ingest something that already has filters applied to it, ingest those filters and display those filters in like Buckaroo, or export, like maybe that was sort of what you were talking about, but like export those like the filters that you applied, the views that you applied as like a file that you can then like share. Does that make the question make sense?
I think so. So can you save the set of filters in the way you've configured Buckaroo? So let me show you in the extending notebook. So one of the other things you can do is you can actually change when Buckaroo chooses which styling method for a column. So you can apply different date time formatters. But what we've done here is we've written two analysis and, oh, not there. We've written two analysis and we've extended the list of analysis classes that are built into Buckaroo, and we put that in its own class. So now you can use this VC Buckaroo widget any place you want to. So that's a way of saving it with Python code. Yeah. At the end of the day, you're going to be serializing Python functions, which gets hairy, and you have security problems there. So if you want to do something like that, I would say, so there's the configuration of what did I select here, that bit. Oh, actually, maybe this answers your question. Okay, so that is VCB, so we can say VCB dot Buckaroo state. So we can see we're in view Quinn 99, and we've applied this process. There. So you can save that state. That's there. And you could also reinstantiate Buckaroo and set Buckaroo state with the set of filters, operations, or whatever else you want.
Sorry, so is VCB the data frame with everything already filtered?
Okay, in this cell, we defined some analysis methods. We took the base Buckaroo widget and we copied the list of analysis classes, and then we added these analysis methods we'd written. We create a class of VC Buckaroo widget with these analysis classes built in, and then we call VC Buckaroo widget on a particular data frame, and VCB is the Buckaroo widget instance. So as an example, and I'll just turn off, I forget how I turn this off. Well, I'll go, so we're in Quinn 99 now, and if I just change this to main, so we're setting vcb.buckaroo state. So if you save that dictionary, you could bring it back and do other things with it. In the back? Oh, sorry, yes.
I have one question with respect to time series data. So for example, in a scenario where you have a specific numerical metric, and let's just say you have a time series data and the metric sort of varies, across, let's just say, months and days. So does Buckaroo allow us to sort of visualize on a hierarchical level, like for example at the level of the day, the month, of the year, so on and so forth?
So there are two ways you could approach that. One, you could use the low-code UI to do a group by, and I don't have, or no, you want to do resample. So you want a date time index on your data frame and resample to the frequency that you want it. I don't have that functionality in the low-code UI, but I'm gonna sit down and write it. The other thing that you could do is, so these are histograms. I've also thought about adding a line chart where like you could just see which way is the value going for that column over time. These aren't full-fledged charts. They don't really have an axis. Those are some of the things you could do. Happy to talk more about it. Like,
A very non-technical question.
yes.
Which is when you're designing or when you're like choosing what shape to then next, which is your ideal target user that you have in mind? Like who would be the ideal person to use Buckaroo?
Anyone who's typing df.head first. I'm building it for experienced users. Like, yes, it spits out Python code. I don't think you should use this instead of learning how to use pandas. I think you should use Buckaroo because you're tired of typing the same code. But did you have an ideal user in mind?
I don't. I'm asking like who would be like a good like would this be someone that's I don't know like an analyst today, someone who like wants to like figure out how like a data set works and how it looks like because they want to like I don't know, build a machine learning model or just create a presentation or get some insight? Would it be more someone that is more on the sort of hardcore technical side trying to like build a data pipeline and trying to get figured out like is the data actually clean that comes out on the other end or does it not matter?
I don't know that it matters so much. Sorry, the question once again was who is Buckaroo ideal for? I think Buckaroo is ideal for anyone who's looking at data frames in a notebook environment. One of the differences with how I built Buckaroo versus other table libraries, and there are a lot of table libraries that are great. Great Tables is an example. Great Tables is set up as here is a static display at the end of your processing. So you know exactly what's in your data then, you know what the columns are, what the ranges are, you've cleaned it all, and that's great. And Great Tables can do a lot more formatting and produce a much prettier table than Buckaroo can. Buckaroo is built for interactive use cases where I don't know what kind of data frame is going to come into Buckaroo. And you just have to make guesses and do the best you can for here's how you can display this. And they're the same things that I do, I think most data analysis do, when they're like, oh, well, obviously I should apply this function, or I want to display this in this way. But because of the way Buckaroo works with functions that do styling, you can encode your ideas into functions and then just get to that result very quickly. Yeah. Yes?
You said there's like a server that's running.
Okay.
Does the user have to start?
This is how any widget and Jupyter widgets work. So you have, with Jupyter notebooks, you have your Python kernel running, which can be running on your machine or on a foreign machine, and then you have JavaScript running in the browser. And Jupyter Widgets provides that two-way communication. So you set a value on your widget like we did down here, and then it updates the state in the JavaScript. So you have Python code running wherever your kernel is running.
I think we're running out of time.
Oh, thank you all.
Okay.